Costas is a civil engineer by training and an internationally renowned pioneer in the field of tsunami research and other natural hazards. He is a member of the Academy of Athens and president of its Division of Natural Sciences. Costas, the floor is yours.
Good evening. I would like to acknowledge that some of the ideas that I will discuss with you are Jorn Sellenhuber's and Christos' Zerefos, and I will give the right quotes to my friend Stamatis Krimisis. We exist because the dinosaurs don't. The greatest physical catastrophe known to us occurred 55 million years ago. Here, Dr. Heniotis, I'll go back even faster than you did. A little bit will go back in geological time. So the biggest catastrophe occurred when a meteorite, hit the Earth, and that eliminated, the dinosaurs. The way that happened was climate change. Extreme disasters changed the course of history, as we know extremely well in Greece, from the Bronze Age eruption of the Thera volcano, or, if you go up, in the Norse Greenland, what we now know as Americas, they would be speaking Norwegian had there not been a mini ice age that destroyed the colonies of the Scandinavian countries in Greenland. ΔΕΛΟS, from what we have heard, and there was a lot of emphasis on people coming and going and changing history, it gives us an example, even though there may have been economic and political factors, but it gives us an example of how easily an island and the whole civilization can flourish and then it can disappear. In the last couple, as you all know, in the last couple of decades, in the last 2 centuries, in fact, anthropogenic causes have increased the concentration of carbon dioxide in the atmosphere to levels that we see now that we have not seen in 20 million years. Whether it is man-made or not, this is not the question. In my view, it is man-made. The question is, what do we do about it? Why is this important, and why is it important in ΔΕΛΟS? You're aware of the greenhouse gas. What is happening is, radiation is coming in, it's not radiated back into space. We are now at the point that the excess heat that we're absorbing is equivalent to 4 Hiroshima bombs every second. This is how much excess energy is staying and is not going back into space. What does this mean? This means, to a large extent, all of this is absorbed by the oceans. The atmosphere absorbs a very, very small part. The oceans have a huge heat capacity, so they warm up. Part of what happens there is, of course, the rise in sea level. What we see, and the greatest consequence of climate change, and the way that we are going to see it in Greece, and particularly in places like ΔΕΛΟS, is in terms of the sea level rise. And as we walk past, where we're going to have dinner is ground zero. That place will be gone. And unfortunately, I think some of the people that are here today, they're going to be around when we'll have to take heroic measures to protect the antiquities of ΔΕΛΟS, at least, where we are. At least, the ones that are very, very low. So what are we doing about it as a humanity? You have all heard of the Paris Climate Accord in 2018, where countries have agreed to take measures to limit the temperature rise to 2 degrees and to do everything possible by 2050, 2 degrees compared to the pre-industrial era, and to do everything possible to go down to 1.5. You're going to say 2 degrees. What is 2 degrees? I want each and every one of you to think for a second. Your normal temperature is 36.7 degrees. How do you feel when your temperature is 2 degrees higher, 38.7 degrees? This is the core temperature. It doesn't mean when the average temperature, the atmospheric, the average land temperature increases by 2 degrees, so will yours, but it gives you a certain measure of what 2 degrees rise in temperature means. And this is what is the lower limit of the worst projections. Unfortunately, my talk is going to have some drama, and I'm glad that we're going to have a world-famous soprano, Marlies Pettersson, to complement the drama at the end. Now, how well can we, what do we know? Consider, that the pandemic that we had just had, if anyone told you about 2 years ago that there will be a pandemic and that world travel will come to a standstill and that people will work from home and there will be all these special measures in terms of limiting people's going outside, you would think that this person is crazy. What happened is that the virus spread past a certain tipping point. Beyond that, the consequences were, to a certain extent, unpredictable. And you all remember, all the discussion about that was taking place in March, particularly in the United States, in the UK, in Europe. What are we going to do about it? We were not certain. At this level of technology, our best computational models could not really tell us exactly what the course is going to be and what measures we will have to take. Take this as an example to understand what is a tipping point in a climate. Yes, we can employ all the computers we have everywhere in the world. Are we going to have more reliable estimates as to what's going to happen when we go past the tipping point? Probably not. A tipping point is a tipping point. Beyond that, it's very, very difficult to predict. And you just start thinking about in terms of how bad things will get. So we are at a very similar point, as I said, in climate. And I've been thinking, the kinds of things that we can do, and of course, you all know, the very, very basic things that we're trying in Greece, just like in Europe, we're passing a climate law that's going to limit, is going to have as a goal to have emissions, to minus 55% to what they were in 1990 by 2030, and to be completely carbon neutral by 2050. And this is a lower measure. We're not even sure if this is good enough. But this is how far science can get. I will piggyback and try to think, how can art help us here? Art is by definition out-of-the-box thinking. As scientists, we're more trained to rely on basic principles, build up, and very, very carefully derive physical results and try to understand the world. Occasionally, there are brilliant minds like Albert Einstein, whose total out-of-the-box thinking changed the way we see the universe. Are we going to have a similar person? This is what perhaps it will take in science, another Albert Einstein, to really think out of the box. In the meantime, the way that the place where we need art is really in this kind of out-of-the-box thinking. We need writers to create for us these dystopias of how the future is going to look like. What is going to look, what is it going to be when, the Central Europe is going to be 2 degrees hotter? We need painters to paint, these landscapes that even with our best imagination, with our computer graphics, we cannot really visualize because to a certain extent, all of our computer graphics, everything we think, inside the box. Finally, I want to make a little comment about space, and I will end here. What is the reason for going to space? What is the reason for space exploration? As Stamatis Krimidis will tell you, the number one reason is our curiosity to find out if there is life in different lives, in the universe. And we are taking very, very small steps, and the Apollo mission was a very small step, and Artemis was a very, very small step. This is Stamatis Krimidis. If you talk to, if we will quote the astrophysicist Stephen Hawking, Stephen Hawking thought that perhaps, going into space had another dimension. Of course, dimension number one is trying to figure out if there's life in the universe. But there's another dimension. What happens if we totally screw up here on Earth? And we're on our way to it. Going into space gives us, humanity, one chance of survival. Thank you very much.